G'day. In a previous video we looked at the unit circle, and when we looked at the unit circle we were able to decipher this formula up here, sine squared x plus cos squared x equals 1. And we're able to work that out because we were able to calculate that the x coordinate was cos x and the y coordinate in the unit circle was sine y, or sine theta. And together, if we actually add those, we get 1. So a quick review. We had sine theta here, we had cos theta here, and we had 1. So if we squared these, then just like Pythagoras' theorem, the sum of these two would give me the sum of that. And this is what we're going to be using today to help us work out the exact values for unknown trigonometric points on the unit circle. So let's get into it. We've got 2 examples to look at today, and then we'll look at a couple more examples later on. So let's have a look at them. Find the possible values of cos theta for when sine theta is equal to negative 1/3. So we can start off and say, you know what? I've got all this information in this calculation here. And by the way, it doesn't really matter, I'm going to put theta here, because we're dealing with theta. It doesn't really matter if I put cos or sine first, because you're adding them. What I do know is that I'm trying to find what cos theta is by itself. And what I do have is I have that sine theta is equal to negative 1/3. Remember that sine squared theta is just the same as writing sine theta all squared. So what I can do here is I can replace this sine theta with negative 1/3. And I'm going to square all that. I then add to it my cos squared theta and equate it to 1. And now it's just a matter of rearranging the equation so I get cos theta by itself. So let's work out the answer over here. We get 1 squared over 3 squared. Well, that's going to give me 1 over 9 plus cos squared theta is equal to 1. We bring our calculation across, so therefore cos squared theta is equal to 1 minus 1/9, which is the same as 8/9. And the last thing we have to do, just like we look at this, if we're looking at this the same as Pythagoras' theorem, we have to get rid of that square right at the end. So we then get cos theta, we square root this side, we square root the other side. So what we get is we get the square root of 8 over 3, because I can square root 9. And if we wanted to simplify this, this could become 2 root 2 over 3. Remember that the rules of surds, I'm not going to go over in this video. Okay, we can simplify that surd to get a more simple answer. Now, the last thing we have to do is, because we are dealing with values here, because we're square rooting, this could be either positive or negative. So if we look at this in terms of the unit circle, there could be one on either side of that unit circle. So one on the negative side, one on the positive side. But you always have that. Whenever you're square rooting, you're going to have those 2 possible answers. Let's have a look at this second example we have here. So it's asking us, find cosine theta if sine theta is equal to 2/5. But we're now within a certain range. We want to find out what it's going to be. So we're going to do the same kind of process over here. We're going to start off with what we are actually manipulating and replacing everything. So therefore, we get 2/5 squared plus cos squared theta is equal to 1. We solve this to get 4 over 25 plus cos squared theta is equal to 1. Bring this over to the other side. Cos squared theta is now equal to 21 over 25. And then we square root it. So, therefore, cos squared theta is equal to positive negative the square root of 21 over 5. Now, this would be our final answer. However, we've been asked to say that we want to make sure, we want to work out, well, what would it be if it's in a certain section of the unit circle? So if we come back to the unit circle and we put this in the middle here, it looks like a unit egg, but let's just deal with it for now. We've got 2 pi, pi on 2, pi, and 3 pi on 2. And we also know that this here is where everything is positive. So it's telling us that we want to look at this region only. That's where it's going to lie, that's where we want to have a look at, between pi on 2 and pi. Well, we know that only sine is positive here. So therefore, the only answer, possible answer I can get for cos would be cos theta has to equal negative root 21 on 5. Because only sine is positive in this section. Yeah, I'll see you next one.